everyone, in this video we are going to learn about the events and probability. These are the definition of the terms in this topic. Experiment is a process that can result to at least two possible outcomes with uncertainty as to which will occur. Random selection means every element has the same opportunity of being selected. Outcomes is the different possible result in an experiment. Sample space is the set of all possible outcomes of an experiment. It is denoted as capital letter S. An event is a set of outcomes that satisfy certain specific conditions. Thus, event is subset of sample space. For example, a fair die is tossed. The sample space is from number 1 to number 6. If A is the event of getting odd numbers, then A is 1, 3, and 5. Complementary event is denoted as A prime or A bar. It is the event that includes all the outcomes for an experiment that are not in A. The probability that the event A will occur is denoted by PA and defined as NA over NS, where NA is the number of possible outcomes in A and NS is the total number of outcomes in the sample space. These are the basic probability law. The first one is the probability of an event A always lies from 0 to 1. The probability of an event A that cannot occur is 0 and called as impossible event. The probability of an event A is a certain to occur is 1. It is called sure event. If A prime is a complement of event A, then PA prime is equals to 1 minus PA. Example 1 is a fair die is tossed. What is the probability of getting odd numbers? When a fair die is tossed, the sample space is from number 1 to 6. So the number of outcomes for sample space is 6. Let A be the event of getting odd numbers. From the sample space, the odd numbers are 1, 3, and 5. Thus, the event A is 1, 3, 5. So the number of possible outcomes for event A is 3. Now we can find the probability of getting odd numbers from tossing a die, and it equals to NA over NS. Substitute and simplify. Example 2 is two fair coins are tossed. Find the probability of getting at least one tail. When two fair coins are tossed, the possible outcomes are shown in the table. So the sample space is HH, HT, TH, and TT, where the number of outcomes is 4. Now let A be the event of getting at least one tail. From the sample space, the outcomes with at least one tail are HT, TH, and TT. Thus, the event A is this, with number of outcomes is 3. Now calculate the probability. Example 3 is Awang has a set of 8 cards numbered 1 to 8. A card is drawn randomly from the set of cards. By using a Venn diagram, find the probability that the number drawn is 8 for question A and not 8 for question B. So we draw the Venn diagram first. The sample space is number 1 to 8, where each dot represents the card's number. Let A be the event that the number drawn is 8. Thus, event A only has number 8. So from the Venn diagram, we can clearly see that the number of sample space is 8 and number of event A is 1. So for question A, the probability that the number drawn is 8 is equals to 1 over 8. Question B is find the probability that the number drawn is not 8. This means that we want to find the complement of A. From the Venn diagram, A prime is all the elements outside the circle A, where it equals to 7, so the answer is 7 over 8. Example 4 is one student feels that the probability of him getting a grade D in statistics course is 1 over 8, and the probability of him failing the course is 1 over 16. What is the probability of him getting a better grade than D? To solve this, we define each event first. Let A be the event that the student gets grade D, where the probability is 1 over 8. Let B be the event that the student fails the course. The probability is 1 over 16. Then let C be the event that the student gets better grade than D. This probability is the complement of the other two probabilities. So just subtract the other two probabilities from 1 and we get 13/16. Example 5 is, there are 12 bulbs in a box, 3 of which are defective. 1 bulb are selected at randomly from the box and replaced. Another bulb is taken from the box. Draw a tree diagram. Before we draw the tree diagram, we define the event first. Let D be the event of selecting defective bulb. Thus, D prime is the event of selecting good bulbs. So imagine that we have a box of 12 bulbs, which has 3 defective and 9 good bulbs. Now we take 1 bulb from the box. The probability of selecting defective bulb is 3/12, and the probability of selecting good bulbs is 9/12. So this is the probability for the first selection of bulb. The selected bulb is replaced back into the box. So the box still has 12 bulbs, which 3 are defective and 9 are good. Now we want to take another bulb from the box. So the probability of selecting defective bulb is still 3/12, and the probability of selecting good bulbs is 9/12 for the second selection. The final outcomes are both defect bulbs, the first one defect, second good bulbs, the first one good and second defect bulbs, and both good bulbs. To solve this probability, we have to refer to the tree diagram from A. For question 1 Roman, we want to find the probability that both bulbs are good. That's mean probability D prime, where it equals to 9/12 multiplied by 9/12, and the answer is 9/16. For question 2 Roman, we want to find the probability that both bulbs are defective. That's mean probability DD, where it equals to 3/12 multiplied by 3/12, and the answer is 1/16. For question 3 Roman, we want to find the probability at least 1 bulb is defective. That's mean it is the sum of probability DD, DD prime, and D prime D. The probability for double D is 1/16. We already calculate this from question 2 Roman. For probability PDD prime, it is the multiplication of 3/12 and 9/12. For probability D prime D, it is the multiplication of 9/12 and 3/12. So the answer is 7/16. Or, we can use the other method to solve, where we subtract probability D prime from 1.